All right. Welcome to the stream, everybody. My name is Nick Larson. Today is October 2nd, 2019. It is 12:03 in the afternoon, and happy Wednesday to you all. Um, I kind of want to just get started. So, here's what's going on. Uh, I have a project to work on today. We're going to do a little bit of work around something that I'm working on at work. Actually, before we get started, let me throw some shout outs here real fast. Thank you for the follow, Matt Attack, JGE Othurg, Instafluff, PHPJS Web Dev Dade, something along those lines. John Galloway, Zom Chicken, and the Dramatic Pause. Thank you so much for all of that. Okay, so let's go to Stack Overflow for a moment. And let's go to the jobs page. If you didn't know that there is a jobs page on Stack Overflow, well, there is. Here it is. And if you look at these sorts of things and you click through, you'll notice that there is this thing right here called a role. And there are also these things called tags. Okay, I should zoom in a bit so we can actually all see this. Maybe throw it over here. Okay, here we go. All right, so we have these roles. This one's a system administrator job. If we go back, what you'll see is like, okay, this one is mobile development, web design, web development. Oh no, those are industries. This is mobile developer. That's the role. And it has these tags, right? So different tags for different things. Right now, the models that we have that show this, so we call this right here, I'm going to make this even bigger. We call this right here the matches tab because the sort is done by matches. This model was generated by somebody who used to work here named Aurelian Gasser. He left and became a data engineer. I can't remember the name of the company, but you know, everything's awesome for him. And what we're trying to do now is sort of update the model that he has. The big thing that we're trying to do is that these job roles map in the background to some concepts that don't exist here on the front end. And they're very similar, like system administrator isn't exactly system administrator. It would map to things like DevOps, or system administration for Windows, or system administration for Linux. There's a number of things, and what we did is we removed those unseen concepts. So now the only things that we target on are things that are actually shown here on the page. And what we need to do is figure out a way to sort of expand this as easily as possible to like generate as much information as we can. All right, there are a number of ways that jobs end up on Stack Overflow, and depending on which ways they get there, we sort of run out of well, what's the right way to say this? Depending on the ways they get there, they come with different kinds of information. The different kinds of information is like sometimes they don't come with tags because not all websites, not all job posting websites support tags. Some of them will have the job description contain all the stuff, like this one, for instance, right? You'll notice that there's nothing about the company until you get down here at the bottom. And then also there's no like requirements section. They just sort of put it in here and you sort of have to like figure it out. Whereas if we go to something like this, you'll see, okay, this is another one where they put their own thing for requirements in here. And if we keep looking through, job description, nope, maybe one more, and then I'm going to give up. You're just going to have to believe me. All right, job description. Yeah, no. Okay, you're just going to have to believe me that there are multiple sections when you post a job, and job description is one of them. I can't actually show it to you. Job description is one of them, and there's like a requirements section, and then there's an about the company section, but the about the company section goes away if they have a company page, and then you can just like click directly through to their company page like this, right? This is their company page, and it's got, whatever it is that you want to know, like their industry, how big of a company is it, what's their status, can I find out some more information about them, go to their website, that sort of a thing. What is their tech stack here? Can I see a little bit of information about whatever it is that they have going on? And these are the sorts of things that you can find out when you click through here. But usually, and maybe usually is the wrong word since I got 4 tries here and didn't find a single one, there is 2 sections. There's like, the details, the technologies, the description, and then there's usually another section for responsibilities. But I don't see it. Anyway, it's not super important. What's important is that depending on how the job gets there, some of the fields are missing. And what we want to do is we want to use the fields to sort of figure out what these things should be, if that makes sense. So when something comes into Stack Overflow, we have a tool called the auto tagger, and the auto tagger goes through and like looks at things like the title and the job description and says, can we figure out like how we should target it in these back-end concepts? And since those back-end concepts don't exist anymore, it's really important that we get the other things right, that we get the role right, that we get the technologies right. And all of these things are sort of, handwritten. Like once they come in here, whoever the account executive is that's responsible for this actually fills this stuff out to make sure that it's correct. And that's sort of what we want to avoid. So what we're going to do something fairly naive for today, just to see what we can get done in the amount of time that we have. What we're going to do is take the tags and see if we can predict what the roles should be. So I'm going to first collect a data set of all of the roles and the tags for jobs that we know both for. And then we're going to see if we can create some predictive model that, given the tags, will tell us what the role should be. And see if we can measure, how accurate we are and all of that. And that's the goal for today. So let's go ahead and get started. Woo! Gotta drink that water. Okay. I am going to do this in R, and almost certainly I'm going to show something I'm not supposed to. Nope, got it done. Okay, let's close this. I'm going to have to do this part off screen because I have to connect to our actual databases in order to get this. Actually, I could probably do this from my local instance. I just can't show you where it is, and then I can just save it as like a giant CSV. So I have a local instance of jobs, the jobs database, and I'm going to pull it from here. Unfortunately, I am not allowed to show you the schema, so I just got to figure this out for myself for just a moment here. Hopefully it turns out to be just a single simple query. Job, columns, oh my lord. All right, we're looking for something called a role. Developer roles. I'm going to guess that's it. Why are there 2 of them? Okay, select. Job. Tags. Developer roles. Okay. Developer roles override equals 1. Then developer roles override else developer roles roles. Okay, I think that's going to do it. Let's do a where Okay, so basically I'm telling it, I wrote a small SQL query here to tell it to go and get me the job ID, the tags, and the developer roles when there is tags and there is developer roles. And ideally when I do this, there we go. All right, we got about 140,000 rows. Let me save these. Copy with headers. Open up a text file. New file. Ooh, I don't like tabs. Let's go with Control H. Replace tabs with commas. Replace all. Hey, 83 people from C# Fritz. Hey, thank you so much. So, for all of y'all who are just coming in, I don't have a defense yet, but it's just me in here anyway, so I'm doing my best. All right, that's awesome. Thank you so much. I really appreciate this. I'm not going to announce all of the follows right as you get in here, but I really appreciate everybody who follows me today. Just so you know what we're working on, at Stack Overflow here, we have changed the way that we build models on jobs when they're posted through our API to get rid of some like hidden concepts that never make their way to the front end. And we now only use stuff that's on the front end. So what I need to do is write a tool that takes the tags on a job listing and predicts what the role is going to be for that job. And that's what I'm doing. Currently, I just collected all of the data. I am saving it all to a CSV, and then we're going to load it up and get started. I hope you had a great stream today, C# Fritz, and I really appreciate this, man. Let's do this. All right, I'm just saving a giant CSV, so if you want to see what the CSV looks like, it's right here. Giant CSV. All right, job. It's got the job ID. This job ID is actually something that we can look up on Stack Overflow. Like at the moment, you just go /jobs/this number. It'll take you right to it, and then we can see it's front-end developer, JavaScript, and React. JavaScript and React, front-end developer. So we know we've got the correct data for what we're looking to do. Oh my goodness, I am like blown away right now. Thank you so much, everyone, for all these follows. I'm just like losing my mind. Thank you so much. All right, so let's get to the actual part of getting this into R, and then we're going to start playing around and see if we can build a model that actually does predictions here. We're going to save this as, let's go to datasets. Hey, Nick, do you work for SO or just working on something related? I do, in fact, work for SO. I got my Stack Exchange cert on at the moment. Great to see you as well, man. It was also really fun to meet you at TwitchCon. That was a lot of fun as well. If you folks want to see stuff being built and used in some way, shape, or form on Stack Overflow, this stream is for you. Yeah, thanks, man. And Hugo, man, it's been a while since I've seen you. I really appreciate all the help you gave me for the last couple of projects that we worked on. It's been awesome. All right, let's save this as dev role prediction. Prediction. Let's go jobs to roles. How many Nicks are there in the SO team? I believe there's just 2 of us. I mean, 2 of us on the engineering team. And I am not that Nick. I am the other Nick. If you've heard about a Nick, yeah, Nick Craver, that's right. Yeah, Nick Craver is awesome. That dude is amazing. He spends way too much time reviewing all of my pull requests and telling me how much better I could be. No, he is not my manager. A man named Kevin Montrose is my manager. Twitch alerts are not working very well in general. Right on. Do they ever? CSV. Okay, perfect. So now we've got a bunch of data in a file. Now let's go load up R. Can I zoom in on this? Oh man. View. Zoom. Zoom in. Control plus. Control plus. Nope, that's not doing it. Control shift. Oh, there we go. All right, is this big enough for y'all to see? Can everybody see this just fine? hopefully. I'm just going to assume the answer is yes. Okay, what are we doing right now? We're going to load up some libraries. In fact, we're going to start a little script here just in case I want to reproduce this later. I might post it up as like a, what do you call those? Gist? All right. So our script is going to be first bring in some libraries, and we're going to do tidyverse. In R, tidyverse is a tool set that includes a bunch of packages that are used to looking at data that's in what's called tidy format. If you're familiar with like database normalization, tidy format is like basically sparse matrix form. So you basically have like, you know, the row identifier, the column identifier, and whatever the value is. So first we're going to load this up, and it loads up a bunch of crap to go with it. Then we're going to use one of the things in here to load up the data called, let's see, this is job tags to roles equals read CSV. The name of the file is I put it in datasets. I put it in, what? This is awful. Should be better at this. Anybody have any idea where I just saved this to? Control Shift S. Dev role prediction. There we go. And these need to be escaped, or we can just / them. That's right, I have a drive named P. Okay, we got double character. Now what we need to do is we need to transform this data. What you'll notice is that the tags actually have more than one tag, and that's not super awesome. So instead, what we want to do is say something more along the lines of, it's got a drive named V for VMs. Get to the gist of it. Okay, so what we need to do is split the tags and maybe the roles as well. So let's just take a look real fast. We're going to say job tags to roles, distinct on the roles, or rather count on the roles, order, no. And then we want arrange, and we're going to say arrange by in, and then we're going to view this. Okay, so the roles can also have multiple roles, so we need to split both of these. And we need to have all of those tags mapped to all of those roles. And then as we get down to the very bottom, you'll see that there is going to be a lot more that are just like singles. All right, so that's what we need to do. We need to split these. We're going to say job tags to roles, mutate, or rather transmute. The difference, so in R, you work in things that are called data frames. If you know all of this, just please tell me to move on, and I'll be more than happy to. But in R, basically, you're working with things that are called data frames, and it's like what you would consider to be a database table, right? So you've got columns that have names, and then you have rows, and all of the items in the same row are like logically linked together. When you say you want to mutate, you're saying I want to add some rows, right? I want to mutate this data frame to add in additional rows, and you can do whatever processing you want to do on them. When you say transmute, you're saying only keep the stuff that I say, but also we can do some transformations as we go. So when I say transmute, I'm going to keep the job ID, Then I'm additionally going to say I want to split. We're going to say tags equals, we need a way to split this. And this is going to be string split. The string is going to be the tags. Sounds like whoever wrote R had a side hobby as an alchemist. Ha. A little bit, probably. You'd be surprised once you get familiar with it, and like I am not going to be the world's greatest example of this, but once you get familiar with R, for the most part, you can sort of grind through things pretty quickly. It all gets pretty easy, especially when you get to the part of actually doing the learning. Everything sort of uses the same format on the input, so as long as you know how to get things into that format, it becomes really easy to like use basically any method you want to learn. But yeah, again, it's one of these things where it's like there is a pretty steep learning curve as far as like using this stuff. We're gonna see if I can remember how to do this. That's gonna be our tags, and then the other thing that we want is, what is the other thing that we want? The roles equals string split. One of the things that you have to understand about R is that everything is an array. There is no such thing as like an atomic singular value. Even if it appears to be a singular value, like within the code, within the actual data structure, it is actually an array. It seems really cool. Is R the same as R script in Power BI? I have no idea, but I'm going to guess that the answer is yes. I guess we could just look that up real fast. R script Power BI. I know that R is supported natively in SQL Server, so everything that you're doing here, I mean, you have to turn it on. It's like a feature that you have to enable, but you can basically like create models right inside your database, and then you can use the database as an API to like execute models against data that exists in your database. Power BI 3-minute tips transforming data with R scripts. The answer appears to be yes. Let's see if we can skip.
You have to try Monday.com. Monday.com is a platform to track.
Welcome back to another Power BI 3-minute tip. If you're liking this,
skip,
on our data,
skip, skip. There we go. That's an R script right there. Yes, the answer is yes.
I'll show you.
Okay, for this one we want roles, and again we want space. And then I'm just going to see what this looks like. I don't know if we can directly unnest this. Let's try it. And then there is another tool. This little operator right here is called the pipe operator. What it does is it says whatever came before this is the first argument into the next function that I pass it to you. So the real way that this looks is like this right here is short form for this. Job tags. It's exactly the same thing. You're just going to find out that if you want to start nesting these, it turns out that the last operation that you want to do becomes the first one that you read, which is really difficult to understand. So instead, if you use this pipe operator, we're saying take this thing, pass it into this function, take the results of this function, pass it into the next function, and so on and so forth. And then you get to actually read it in order. This is one of those things that just makes it like a whole lot easier to understand as you go through it. Yes, almost. Well, I'm not 100% sure how pipe works or pipelines work in PowerShell, but maybe. I equate this a lot to like fluent languages or like fluent APIs in most languages, where you have one thing and whatever the result is becomes, has functions that you can call. Link is actually pretty good with this in like C# or .NET. What I want to do now is unnest tags. I'm going to have to look this one up. Tags roles. All nested columns must have the same number of elements. Okay, so that worked, which is sort of frustrating. Must have the same number of columns. What if we go like this? What if we just, instead of this, we say mutate? Again, this is the thing where you have to hack it into the format that it expects. We're going to say mutate, and on this one, it will still have the other one. Basically, all we're going to do is rewrite tags and replace it with this. Then we're going to unnest them. Okay, great. And now we still have the roles and we have the tags broken out. And then we're going to basically do the same thing again. Mutate roles equals string split of roles. That will give us that. And then we can just unnest roles. And it would honestly be faster if we did these backwards. So let's do these backwards. It would be faster because what's happening is we're taking these tags and we're splitting them, which generates roughly 3 times as many rows. And then we're trying to do this to 3 times as many rows, whereas most jobs only have a single role. Basically what I'm getting at is we had 643,000. No, wait. All right, we had 573,000 when we did it like this, and we only have 151,000. So instead of having to do that second split 500,000 times, we only have to do it 100,000 times. All right, and then we're going to take this and we're going to save this as all data equals this. Great. Let's take a look at all data. And there we have it. We have 147522 is a front-end developer only, and it has the tags JavaScript and React. So now basically what we want to do is learn what tags map to what roles. And then we want to predict given all the tags, how likely is it to be a front-end developer role, and then a back-end developer role, and etc., etc. All right, that's what we're trying to predict here. So given a collection of all the tags. All right, so the model that I have in my head for this is that each of the tags is going to be a binary feature, and we are going to train a model that will predict each one of these features independently. So we're going to say, given all the tags, decide whether or not it's a front-end developer. Given all the tags, decide whether it's a back-end developer, and et cetera, for each of the different roles that we have. And then we'll just take the one that ends up being the highest. And that is sort of what I am thinking for like a really naive first pass here. So what we need to do is we need to say, for each job number, this is going to be the column. For each tag, we want it to be a binary feature, true or false. And then we want these to be the labels. Okay. So rows. So we're going to make a matrix. And it's going to be job ID to tag. And the value is going to be 1, and the rest of the values are going to end up being 0. Okay, that shouldn't be that hard. Let's do some splitting of the data here so that we have some training data and some not training data. And the best way to do that is by sampling the job IDs. Okay, training IDs. Equals all data. Distinct job ID. Sample frac of probably something like 0.8 we'll use for the training data, and we'll use 0.2 for the test data. Let's just get all IDs. Then let's say training IDs equals all IDs, sample frac of 0.8, and then we want test. Oh wait, nope. You should, anytime you're going to run something like randomized, you should probably set your seed for reproducibility. Set.seed. What is today? 2019. Oh, nope. 1002. Now let's do this. So if we look at these training IDs, we see we have 109.965, 96883. We want to see the same thing if we run it twice. There we go. Same thing. It didn't change. Perfect. And then we want test IDs equals, and then we want test IDs equals all IDs except, no, we can't do except. That would have been way too easy. I don't know how to do this. Let's Google. So I'm going to write a Twitch plugin that counts the number of times that I Google during any conceivable stream. R language. Difference of two vectors. Difference between two vectors in R. Set diff. Well, that was easy enough. Set diff. Not what I wanted. Up here. Set diff of training IDs. All right. So we have 109.530. Let's go look at all IDs. Let's just do the old lin of training IDs plus lin of test IDs. I'm just making sure that we actually captured all the IDs here. That was fun. I told you everything's a vector. I'm just going to do it in my head. Let's see. All IDs ends in a 2. We have an 8 plus a 3 that has a 1. We have a 3 and a 5 and a 1. That's a 9. 9. Okay, we're back to the easy part. We have a 16, 36, 130. Okay, I'm convinced. Okay, I think the correct way to do that, just for the sake of argument, was 0. Oh, that's another thing. It's 1 based, not 0 based. I just can't figure it out. And then I think we want to do 1. I don't know. Whatever. See, some things in R are hard, like adding numbers together. But everything else is alright. Let's keep going. 1 based. That's it. I'm out. I feel the same way. Like, I can't tell you how many bugs we've run into because R is one based. And when we're like converting a model from being written in R to being written in C sharp, it's just like really dumb stuff like that. It's frustrating. Okay. So now we have training samples equals all data. And what we want to say is job ID equals training samples, training IDs. What do you mean job ID isn't found? How about we do this? We do the more appropriate way of filter job ID in training IDs. There we go. Test samples equals, as long as it's not abused, like option base 495. Oh no. Goodness. I don't think I've ever seen that option. I've done quite a bit of work in VB Classic, but I have never seen option base used. Does it seriously just like treat numbers as base 495 or whatever? Training samples, no, test samples equals all data. Filter job ID in test IDs. Okay, now what we want to do is transform these into labels and like data. That's what we want to do. Let's just get the labels because the labels are super simple. It's ridiculously simple. Training labels equals training samples of select job ID and roles. I guess I should have called it role. Yep, whatever. So option base 459 would return 459 for L bound your array. Interesting. It sets the base index for arrays. Oh, that's awful. Oh, God. I can't think of a use for that. Aren't most options like file that like the, or don't most options apply at like the level of the entire file? That would be ridiculous. I cannot think of a valid use for that. No, not really. Oh, I got it. Oh, okay. Okay. That's still disgusting. um, that's going to be our labels. Test labels equals test samples. Select job ID roles. And then we want the... How are we going to do this? We're going to be... These are going to be enormous, ridiculously enormous if we actually make them... All right, so I need a way to get to a matrix from an already sparse selection of values for I equals L bound. Oh, interesting. I'm glad I'm just a little too young to have worked with VB apps proper. Okay. We are trying to I want to all right, this is my second Google. We're just going to keep count here. Convert tidy data frame to a new. Welcome to the show. Thank you again for the follow. I'm going to go ahead and rip over the follows here after I get done figuring out this one little bit. Convert a tidy data frame to a sparse matrix. It needs to be a sparse matrix here because there's hundreds of thousands of rows, but really the idea is that the number of tags there are is in the order of, like, call it 12,000 tags, and if we don't use and only a maximum of 5 exist for any job, which means that we would take a length of 5 and expand it to 10,000 for every single of the 130,000 jobs that we have, which is an enormous amount of data. And I'm not sure my computer would even be able to handle that, and I have quite a beefy computer, so I need this to go directly from being in tidy format to a sparse matrix. Library matrix. Sparse equals true. Regular matrix. What is regmat? Yeah, see, I need this to be sparse from the get-go. I have a regular matrix, non-sparse. Actually, you do have a sparse matrix. Matrix with mostly zeros. It's just an uncompressed format. Your goal? Compressed sparse column matrix. Okay, here we go. This is what I'm looking for. I got a data frame that's got row indexes, column indexes, and values. And I want to go sparse matrix directly. Yeah, I can do that. Okay, that's how we do this. Okay, we can do this. Let's do this. Let's give this guy a little vote here, which of course I'm going to have to sign up. So actually I'm just going to leave this open so I don't forget it. All right. We're just going to call sparse matrix directly. We're going to pass in the row indexes, the column indexes, and the data frame values. Let's just see if it works. Okay. So we're going to have training data equals training samples sparse. I guess I have to have matrix in here. Sparse matrix. Okay, so let's just do a library matrix. Pull that in. And then we can just call matrix sparse matrix directly. And then we have the row indexes. Was there any special syntax here? IJX? Sure. Whatever. IJX. I equals training samples of job ID. J equals training samples of tags. And X equals repeat of one sequence. Generate regular sequences is a standard generic. Okay. Let's do repeat because I feel like it's repeat. Replicate elements of vectors and list. Rep X. It is a generic function and the internal default method is described here. So times okay. Rep 1 length of in rows of training samples. Non-numeric argument to binary operator. Oh. That sucks. Okay. So we need tags equals. So the problem that it's complaining about here is that tags is like a column name and not an index number. So we need to make a list of all the distinct tags. And then we need to look up an ID for each one of them based on the tag name. So that we have actual numbers. And then we can change the names later on, but for now, we're just going to have to do it like this. So we want training samples. Seems like a lot of R for the 30 minutes I've seen you do. That's right. Like I said, yeah, once you get the data transformed and into the correct format, everything after that becomes really easy. It's just you have to get to that step first. Also, I am not the world's greatest person with R. I'm sure there are ways to do this where it's just like you write one function and it's like, okay, you know, give me one hot vectors for all of these values. In fact, maybe we should just Google that. One hot matrix R one hot matrix for tidy data frame. Encoding categorical values. Sometimes you have to go through the worst way to understand when someone shows you a better way. Totally agree. How to one hot code train outcome dummy vars ID outcome I'm not quite understanding this. Oh, I see. Okay, so this is what the input is. It's 10, 20, 30, 40, 50. You have male and happy. Oh, I see. Okay, so if what we had was I like functions that are just called one hot. That's so much easier. ML tools, one hot. But I need this to be sparse because I can't expand this. It will just destroy my computer. Thanks, I really appreciate that, TBD Gamer. Alright, I'm just going to go back to the way that I was doing it, and then I'm going to ask somebody at work who is much better at this than I am, and I'm going to have them tell me the answer. So I am going to take training samples, and I'm going to get distinct tags, and then I am going to mutate this, and I am going to give them tag IDs equals row number. So now we should have, if I just say tags down here, we have 0. That's freaking awesome. I don't even want to do training examples. I want to do all data. No, I don't. I do want to do all data. Okay, all data, distinct tags. All right, we have plenty of those. Mutate tag ID equals row number. Okay, exactly what I wanted. Can we work this time? Yes, we can. All right, great. Now we have 12,755 tags. All right, that's what I was trying to get to. Now what we need to do is look up that row number, that tag ID. So we're going to say tags, tag ID, tags, $. In R, you use a $, where you would use a dot in most languages. A dot is just like a valid character in a name. So you can have like Nick.Larson equals 3, right? And then Nick.Larson is the actual name of the variable. And that is mind-boggling to me, and I don't understand how that works or why they would choose to go this route. I'm sure there's some historical precedent in whatever language this is a derivative of, but I strongly dislike this. All right, so tags of tag, and then we want to take what is the right way to do this? I want to take, how do you select based on one column and get the value from another column? Or select value from one column based on value from another column. Extracting value based on another column. Right. So if I have a frequency, as Justin said, data frame, true, false, df. This is what I'm looking for. Okay. So I'm gonna say it's something along the lines of training samples. Yeah, training samples tags equals tags. No idea. Actually, we can just run this directly and we'll know the answer. Unknown tag. Tags? Tags. Oh, I don't want tags. I want tag ID. training samples. I like the Python syntax for this. How would I do this in R? I don't think this is going to work. Because I'm saying only give me the ones where this matches. I don't think this is going to work. Yeah. Okay, so I want the tag ID. From where the training samples, maybe it's just training samples tags. No. Maybe. No. It's a match. Okay, it's match. That's what I want. Return a vector of the positions of the first matches of its first argument and its second. Right, that's what I want. That is exactly what I want. Give me an example. Okay, 1 through 10 in 1359. This should just return 1359. Oh, there we go. 1 through 10, so I need tags in. Let's get this sorted out. We can figure this out. Tags in. I don't. Yes. Yes, I can do this. Okay. I want the tags of the tag ID where the training sample tags. No. Where tags of tags in training sample tags. This should, what is in rows of training sample tags? Training samples, what the hell? Oh my goodness, training labels, training samples, these are screwed up. How did I get these wrong? Training labels is training samples, which I got 0 from. Training samples, training IDs. Training IDs, I have 100,000. Where job ID in training IDs. All IDs, distinct job ID, where job ID in. Okay, training samples is returning 0. Job ID. All data. Maybe one of those ones I had was correct. All data looks like this. It has a job ID. Filter where the job ID is in training IDs. And the training IDs oh, it's because, yeah. All right. So the problem here is that I needed a vector, and what I had was a data frame, and I needed to tell it, no, just look at this column, because the column, when you dereference the column, is just a vector. So the difference between this, where you see it's a tibble, and then if I were to say training, oops, if I were to say training IDs and then actually dereference job ID, you actually get the full vector there, and that's what I need. Another thing I'm sure I would have been more familiar with. Okay, now we've got all of this stuff. Now we have the tags, the row numbers. Okay. Now we're going here and we're saying where the tags are in the training samples. This doesn't feel right again. I want this to have the length of training samples. Tags. I do want match. We have match open. Show me map. Why is map not in here? Map, match. Get the index of a value. Okay. We want the answer for all of these is going to be true. So let's say R, get the index. Let's keep going here. I think we just looked at that. I'm not entirely sure. X, Y, column indicator, X, new value, match. Data frame, new value equals data frame, column bind, sequence length in rows of data frame, so 1 to 3, match, data frame column indicator, call names of data frame, XY column indicator. I'm not sure I understand this. DF name, extract the entire row, extract the entire column. R match example. Match 5. All right, so that's it. 1, 2, 3, 4. So that's what it is. I want to match the things that I'm trying to match in the values that I'm trying to get them from, and it will give me the indexes. Okay, that's what I'm looking for. That's exactly what I'm looking for. So I want to be up here, and I want to say match of the tags looking in tags. Looking in tags of tags. And in fact, I don't even need this tag ID anymore. I can just use the index directly. Okay. All tags. All tags, $ tags. Hey, there we go. Okay, okay, okay. Woo! Progress! It's like all day, every day. So now we say, just use these indexes directly. And then we're going to put the values of 1 in there. Oh, there's something in there. It did not crap out. We're getting there. A little bit. Training data. Did I figure it out? Large DC matrix. See, that's a lot of elements in a matrix. 2 billion elements in a matrix. I definitely could not have like expanded that. Maybe I could have. What is that, like 8 gig? I guess maybe I could have gotten that figured out, but I feel good about doing it this way. Okay. $12,755 columns, 159,000 rows. That seems like too many rows. Nope. Just kidding. Training samples. Where's training samples? So there's 128 training samples. 515,000. That is how many I would have expected to end up in here. But we only ended up with, oh, no, that's not right. That's not right. Yeah. So the problem here is we have 130,000, 136,000 distinct IDs. So I would have expected 136 by 12,755. And somehow we ended up with more than that for just the training data. So that's interesting. That is interesting. Maybe I need to number these. I don't know why it would do this. Feel like something's wrong. Sam Davey, welcome to the stream. How do I figure out what went wrong? We have 159,000 rows. I guess what we do is we get the names of the rows. That's what we're going to do. We're going to do row names of training data. Count. What do we need this to be? We need to make this tibble. And we're going to say job IDs equals this. Thanks, man. I can't wrap my head around artificial neural networks or perceptrons. Well, we're not quite to the point of learning yet, but maybe we will try both of those when we get there. We have Tibble job ID. Let's just see if that's coming out. No, of course it's not. That would be way too easy. All columns in a Tibble must be 1D or 2D objects. Oh, seriously? The row names are missing? Oh. Okay. I. I must have gotten these incorrect. I, J, X. X in row of training samples. Training samples. Oh, damn. Job ID. I'm really kind of confused here. Training samples tags. Number of columns. It did not complain. Alright, the problem that I'm having here is that it is saying that... Let's just see what this comes out as. Okay, that's the correct size. 514115. 514115. Okay. So these are the same size. These are correct. Hello! How's it going, man? I am trying to figure out why it thinks there are way more rows than there should be. Maybe the thing that we should do yeah, maybe what's happening here is it's saying that the like that to me looks like a maximum job ID is what that looks like. So let's just check that if we can verify that. Yeah, I think what's happening right now is it's saying that like it's treating this as like indexes, like what row number, instead of it being like there are job IDs that get skipped for various reasons. So I'm going to guess that this is the maximum job ID, and what I need to do is basically the same thing that I did here, I need to do for the job IDs, like convert the job IDs to something else. Let's take a look at that. I'm doing great. Thank you for asking. How are y'all? What are y'all doing today? Everybody who's hanging out, what are y'all doing? I want to take the maximum job ID. Max all data. No, training data. Job ID. Error. That's awesome. Training samples. That's even more frustrating. So now, trying to understand what I'm looking at. Yeah, I appreciate that too. I'm trying to understand it as well. Okay, so the part that I'm stuck on here is I am trying to basically create a matrix of zeros and ones, but it's way too big to fit in memory. So I am trying to create a sparse matrix. A sparse matrix is a 3-column like data structure where the first column is the row, the second column is the column ID, and the third column is the value that should be at that location. Okay? So what I have is these training samples, and the training samples are exactly that. Right? If we look at it, oh, that's interesting. We have NAs in here. I want to get rid of the NAs for sure. That's one thing to get rid of. Okay, so conceptually what I'm looking at is I have this job ID and it has 147522 is the job ID. And then what I have is this tag JavaScript. So I created a way to convert the tags into numbers so that I can index them into an array or into this matrix, right? And that's what this is right here, all tags. And then if we look at all tags, it's just a vector, well, in this case, it's a data frame of, but it's just one column, and this column is a vector of values, and we see that JavaScript is the first one. So what I want to do is I want to use this tool called match right here, which gives me the index of each tag in my training to the index that it exists in my list of unique tags. Right? So if I go all the way up here, the first one is 1. Okay? So it found JavaScript and it said JavaScript is at index 1. So now I have an index for each of my tags. I have an index for each of my job IDs, and I want to create a matrix that has a 1 at each of those locations. That 1 indicates that this job ID has this tag. That's what we're looking at. And once I get that figured out, then we can basically just shove that into whatever training method we want to shove it into. The only problem that I'm having here is that, oh, look, here we go. The dimensions are correct. All right, I'm looking at the wrong thing. So I was looking at I and thinking that it was my row numbers, but that is incorrect. What I have here is, this is just the original data that was shoved into this thing. That's what I is. Okay, this makes so much more sense now. The X's are the values, and the P's. All right, so we're gonna do one additional step here, which is to get rid of all of the data that has NAs in it. Let's do one more thing, which is filter role not is.na. Does that make sense to everybody who was lost a little bit? Like, what I'm trying to do is basically create a giant matrix of zeros and ones, and then that's going to be all of the training data, and we're going to put it into our learning algorithm. Okay, perfect. All right, so we have, I want to make sure that we're filtering out any that don't have targeting features. So is.na roles, and then also not is.na of tags. All right, and then we just run all of these again. And now we have training data. All right. All right, we have 158,942 rows. Does that make sense? No. Actually, that doesn't make sense. Because we only have 136,000 original jobs. So somehow there are... It does make sense. Okay, it does make sense. It makes sense because this is where the max comes in. Give me the max. There. Okay. All right, so the max job ID is this. What we should do is take this right here and do the same thing for the job IDs so that they get compressed down as much as conceivably possible. And then what we can do here is we can say training data, and we can say call names of training data equals our tags. Invalid dim names. Okay. Let's go Google that one. Using rename cells with sparse matrices. This was an error in my matrix. Code is fine. Not sure. Error when making a sparse matrix. Does anybody read the question when you go to Stack Overflow? That's a real... That is me asking y'all for real. Does anybody actually read that? Because I literally just start scrolling and see if the code looks sort of like mine. There's a question? Yeah, exactly right. We can convert the PID and CID columns to factor. Oh, I need them to be a factor. That's what I need. Factor. Error. Must use a vector, not an object of class matrix. I'm not going to worry about this. We don't actually need that. Okay. We have the training data. And we have the labels. Let's see if we can get this thing to learn something. All right, so ideally, what we're looking for, you always read it. When you read the question, what are you looking for? When we... Let's just do the most naive thing possible right now. Let's just learn like a linear model, like a logistic regression. And let's see if we can make this work by just saying 1 or 0 is the output variable for whatever it is that we're trying to do. So let's do all, okay, all labels equals all data. Is it all data? I think it's all data. Distinct of roles. And then we want all labels. Okay, there's only 14 of them. That's super easy. We just trained 14 models. Not that bad. So we want front-end developer. So we want to say model front-end developer. And we're going to clean this up and make it like easier to do. But we're just going to see if we can get the first one to actually spit out some answers first. Model front-end developer equals, and for this we're going to use GLM, probably GLM net, yeah. library, glmnet, glmnet, and then you want that's it right there, glmnet. Okay. Our X is literally training data. Our Y needs to be a vector. Okay, so we need training labels bools equals training labels $, roles equals front end developer. All right, what that gives us ideally is a bunch of trues and falses. Yep, true, true, false. Perfect. And then we're going to say these are the labels. Training labels bools. Come on, give me some more. That looks complex. What looks complex? Family, we want binomial. Family equals binomial. What binomial means here is we want to do a logistic regression instead of a linear regression. Like a Gaussian would be a linear regression. A Poisson would be a Poisson regression. Let's see, can I do all of these? I don't know what Cox is. I don't know what... Oh, multi-Gaussian and multinomial. A multinomial... Nope. Can't explain what that is off the top of my head. I just know that this is a linear regression, like a raw linear regression. This is a raw logistic regression, and this is a raw Poisson regression, which pretty much takes care of whatever you'd use. Yeah, glmnet. So actually it turns out to be pretty simple, right? You have this. This is how we do the training. You get the data into the correct format, and then you literally just run this, and it spits out a model. Error. Awesome. I'm so good at this. In glmnet, oh, that's right. What we need to do is say... training labels... okay. This is fun. What we need to do is say something like all right, we need to say in the original one. Okay, let's do this. Let's do the original data. No, because I need them in the order that they are in the training. So I need to be able to tell whether or not, let's group by, okay, let's do it like this. Let's say training labels. This is sort of a hack. Group by job ID. And then we want to say mutate. So now what we have is for any given job ID, all of the roles, we can say label equals front end developer in, what is the other field? Training labels, roles. Okay, let's see if we have that. Training labels bools There we go. We got a true, a true, a false, a false, a false, false. Okay. Feel pretty good about that. And then what we want to do is say this now is $ label. One minor concern here is that I need to make sure that the labels has the same length as the number of rows in the training data and that the IDs line up. Okay. I'm starting to thinking of doing this a little bit a different way. Yeah. Training labels bools. How am I going to get this into that format? I am going to say we're going to take the training labels. I think we're just going to get all the job IDs. Yeah, that's what we're going to do. Okay. I think we have all IDs, don't we? We do have all IDs. Okay, we have all IDs. And we're going to no. We're going to make a vector of all falses. Okay. Training labels. So the approach here is we're going to make a vector of all falses, and then we're going to set the ones where we know there is a training label that matches what we're looking for to true. Equals repeat false. And we're going to do this max all data. No, max training data. Job ID. Max training samples. Okay, so we have a vector of falses that is the correct length. Now we need to set to true all of the ones where the... Alright, so we want this as like training labels has what we want. And then we're going to say training labels bools of same idea, match Training samples tags, all tags. So basically the concept is we just set this equal to true. Like that. I want to say we are looking for the IDs where a thing is true. So I think what we're looking for is this of match that $ label I think that's it. No. I want the what am I? I'm saying in the locations. Oh, wait, here we go. We want to say, okay, let's say this. Let's say, in fact, I feel like we can just do it like this. Group by job ID. Summarize. Filter. Label. And this should give us just the ones where they're true, just to be sure. Let's not even look at this. Okay, this is only the ones where they're true. And then we can say, give me the job IDs. Right, so 11,000 of these 130,000 training jobs have this. Okay, so now we have the job IDs that we care about. And really, we should just be able to say this. Okay. Front end, or just job IDs, front end. And then we can say this is training labels bools, job IDs front end, $job ID equals true. Ha ha! Okay, training labels bools. Let's go find a job ID that has this. Like, for instance, 9139. So what we should be able to see is that if we go to training labels bools, and then view that so I can just see them all at once, then we ought to be able to go to 9139. Come on. Come on. Wow, this is like really going out of your way to solve what should be a simple problem. I'm going to guess there are much easier ways to do this. Come on, 9131, you can do this. 9134. Nine. Oh. 9134. Okay, perfect. All right, all right. Okay. So now I'm convinced that we have the correct labels. Training labels bools is just a vector of bools. Okay. Let's see if this will work. It is actually doing the learning. I can't imagine this is going to take too long. I gotta clean this up. This got real ugly. That's the thing about this stuff. You just don't know how long it's going to take. It shouldn't take that long. It is quite a bit of data to churn through, but it's just not that many samples. Another thing that we might want to do here is cut down to only tags that are used more than X number of times. Let's go ahead and do that. Let's see if we filter this to only tags that are used more than, I don't know, let's just take a look. Let's kill this, because I really expected it to have already been done. And what we're going to do is say, do I want to terminate now? Yes, I do. What we're going to do is we're going to say, can we go to... We're going to take a look at the number of times that any given tag is used, like the number of different jobs that it is used on, and see if we can filter down from there to only tags that are interesting. Like, see if we can cut the number of tags that go into the model from like 12, almost 13,000 down to hopefully around 1,000. And then this will be ideally a lot faster. Wow, this is really bailing on me. Okay, let's just go ahead and start doing what I was trying to do. Let's say we have the training data. Yes, I have already tried to do this. Another way to do this is to go to your task manager and just kill your R session. End task. Whoops. Now let's see if this thing, unable to establish connection, reload. That's fun. There's our all data. All right, now this is one thing that I want to stress is unquestionably, we're going to eliminate this all tags thing for just a moment. You can only do this on your training data. So this is one of the really frustrating parts is your training data and your testing data have to remain separate. So if there is some value that exists in your training data but does not exist in your test data, then you can't learn on it. Like, it can't be a feature in your model. And this sort of thing happens all the time. Like, for instance, in jobs, if a new technology comes around, somebody adds a new tag, we've never seen it before, we can't predict it, we've never seen it before. So you don't worry about that sort of a thing. You just have to remember to ignore it when you're doing the training. And that's super critical. All right, we're going to put a little space in here so we can actually see the difference. And then right here is where we're going to do our tag filtering. Okay. We're going to say model tags equals training samples count tag. Tags. And then we're going to have arrange by descending in. And then we're going to look at model tags. Alright, JavaScript is used in a whole lot of jobs. Basically what we're going to do is scroll down until we get to some small number where we feel like there's no additional valuable information after that. Right? And right now I'm going to go ahead and say 1,000 tags is like the minimum I would want to take here. And now it looks like 15 is a really good cutoff, right around 1,000 tags. Although you have .NET 4.5, it's only used in 14 jobs and a whole corpus of 130,000, 130,000 jobs. Like, it's just not that valuable. So we're going to do a cutoff at 15. This will give us 1,000 features instead of nearly 13,000 features, which is awesome. So we're going to say model tags, filter in greater than or equal to 15. And that now tells us what our model tags are. So now we're going to stick with the same thing here where we have all data. Instead, we're going to use model tags. So anywhere we have all tags, instead we're going to use model tags. Match training samples tags, model tags. Tags. Okay. So we've done all of this. And then I want to filter my training samples. Okay, this is where it starts to get interesting. So we have our training samples. Let's move this up. And then we want to say training samples equals training samples filter tags in model tags. In fact, I would probably do something even like $tags. What this does right here, the dot, when you use a pipe, the dot says give me access to the original value that was passed in, and then I'm saying just dereference tags so that now tags is just a vector and I don't have to keep using that $tags everywhere. So we have model tags, and now I can just say model tags instead of model tags $tags, because that was just going to get really, really old. And then we have training labels. And then we have test IDs, and then we have test samples, and then we also want an additional filter here for tags in model tags. There's our samples, there's that, and then here we don't need this $tags anymore as well. Okay. There we go. All labels. Don't think I actually use that. We create these training label bools. Job ID. There we go. There we go. All right, and now what we'll see is that this training data that we're passing in should be significantly smaller than it was previously. Yeah, now it's only got about 160 million elements, and it's only 2.9 megabytes. So this should go significantly faster. There we go. All right, see, we have now trained a logistic regression model. Now what we want to do is take a look at what we can do with it. Let's do a little summary. Okay. Not a whole lot of particularly interesting information in here. The way that you actually do a prediction is you create a new job and then you run it through. But what we're going to do is just run through the jobs that we already have, and then we're going to see how well we do at predicting them. And the way that we're going to do that is we're just going to say predict. We're going to pass it in our model front-end developer, and then we're going to pass it in. We're going to have to do this. How do you actually do the prediction part? Predict.glmnet. Okay. So now what we need is the new x. Which we're just going to pass in the training data. New x equals training data. And this should spit out predictions. And I think what we want is response. And now what we have is not really what I expected. Maybe I should have made these ones and zeros. Okay. Predictions. What made you choose R instead of Python? I'm doing this for work, and everybody else uses R, so that's what I have to use. If this were something that I was doing in my side time, I might be much more willing to use something else. Really sort of wasn't expecting this here. Let's just do a predictions. Oh, there's our values. How do I get those out? Oh, shit. Okay. What is S0, S1, S2? All of a sudden I'm forgetting how to do this. It's not really helping. Okay. Well, I am forgetting how to do this. All right. I do have a hard stop at 2 o'clock. I can imagine this is a bit of a lot. I thank you for stopping by. I want to thank everybody for stopping by. I have a hard stop at 2 o'clock today because I have to run to a meeting. I would like to throw out a thank you for everybody who followed me today. Let me go ahead. This is the Stig 4242, Z Lucient, TBD Gamer, thank you so much. Pluto Non, thank you so much. Faith Karate, thank you so much. M Holloway 24, Stelzy 79, thank you. Mikalev, thank you. Wild Genie, thank you. GG Feds, thank you. Zorshinheimer, I think. Lards SS, Lard SS, thank you so much. Ask Papa, thank you so much. Rocklebest, thank you so much, and Sam Davey, thank you so much. I really appreciate it. I know this is maybe a little bit much. I'll actually do a visualization, so I'm going to keep working on this for the rest of the week. We'll get into visualizations and show whether or not we're doing a good job probably sometime tomorrow. My normal hours for streaming are from noon until 2 on Wednesdays, Thursdays, and Fridays. Do please come hang out. I'm more than happy to answer your questions. The more on topic they are, the more likely you are to get an answer from me. But yeah, that's it. So basically, the long and short of this is we have a model. I forgot how to actually run predictions. And then once you have predictions, what you do is compare them to what you know are the true values, figure out what your accuracy is, and then see whether or not it was a good model. And that's sort of the direction that we're going here. And this will eventually be converted to C# when we're all said and done. The coefficients of this, that I know that is one thing you can do. Coefficients of model front-end developer. Goodness. All right, these coefficients right here, they're the things that we're trying to do. These coefficients effectively get converted. I'm not even sure what this looks like. I'm starting to feel like I did something wrong along the way here. But these coefficients basically turn into what's called a dot product. It's basically you multiply these numbers together, add up the results of each of the multiplications, pass them through a logistic transformation, and it spits out your prediction. And yeah, that's how we convert this into C#, and that will happen by the end of this week. Hugo Dahl, I had to miss some of it, but I'll definitely try to get back next stream. Hopefully Twitch will notify me, but I also noted your schedule. Thanks, man. Will the same computer be what tells us it's doing a good job? Ha ha. No. It's gonna get a lot more fun. Once you get to the point where you can actually spit out some like predictions and understand them, yeah, it gets a whole lot more fun. Anyway, we've got a few people in here, so let's go ahead and find somebody to raid real fast, which is always a challenge, and then I'm going to run to my next call. I think today we're going to go with Gareth Hubble. Gareth Hubble is working on tokens and calculator in C++. Let's go to pick a live channel. Oh, this is not working. Nope, this isn't working at all. I think something's wrong. Oh, there we go. Gareth Hubble. I'm going to refresh this page so that it refreshes the list. There we go, Gareth Hubble. All right, here we go. We're going to go in about 5 seconds. I don't have anything to spam or anything like that. But again, thank you all for joining. I really hope you come and hang out tomorrow. We're going to keep grinding away on this, and by the end of the week, it'll actually look like something that you might have actually learned from. But yeah, thanks a lot, and I will see y'all tomorrow. Have a good one.